Hi, in this video we are going to discuss how to improve the coverage and capacity of a cellular system. As we know, the number of users, that is subscribers in the mobile communication, is increasing day by day. There are huge number of users, even a person has more than 2 SIMs nowadays, isn't it? And a number of service providers are also available, but there should be some methodology to improve the capacity in a cellular system should be developed, because we know that the spectrum is limited. We cannot expand the spectrum beyond certain limits. It's a natural source, isn't it? So there are certain technologies are used to improve the capacity of a cellular system, which are nothing but cell splitting, cell sectoring, and coverage zone method. So in case of a cell splitting, we are subdividing the congested cell into the smaller cells. In the second method, that is in sectoring, the directional antennas are employed to control the interference and frequency reusing. The third technology, that is coverage zone, we are distributing the coverage of a cell and extends the cell boundary to hard to reach the places. In such a way, we are improving the capacity in a cellular system. So we are going to discuss one by one. First, consider the cell splitting. So as a name implies, here we just split the cells into a smaller cells. That is, congested cells are splitted into a smaller cells. In this point, we have to remind two main factors. One is the frequency reusing. Frequency reusing is nothing but we are going to reuse the frequency for the cells with limited interference, isn't it? So we have to preserve the frequency reuse plan for that cell, and also we want to reduce the transmission power. So power is another important factor while designing the cell, isn't it? With higher power, if you go, then you have to go for a higher end devices, and your antenna factor also get varied. That will increase the cost of the entire system. So we are splitting the congested cell into the smaller cells by preserving the frequency reuse and also reduce the transmission power. This is the simple illustration of a cell splitting within a 3 kilometer by 3 kilometer square. So in this, we are splitting the cells into a number of smaller cells. Here the transmission power is reduced from PT1 to PT2. You say initial power is PT1 and now we are reducing the power to PT2. Now we are examining the receiving power at the new and old cell boundaries. Consider the old cell boundary where your power is directly proportional to PT1 into R. R is the radius of old cell boundary. Now you consider the new cell boundary where your power is directly proportional to PT2, that is the new power, that is the reduction power, into R by 2, where R by 2 is the new radius of a reduced cell, that is splitted cell. Suppose we take n equal to 4 and set the received power equal to each other, then we could define PT2, that is the reduced power, is equal to PT1, that is the earlier power, it's a high power, divided by 16 for n equal to 4. So this is the simple formula. In this way we can able to calculate the power for a splitted cells. And also in this case the transmitted power may be reduced by 12 dB in order to fill the original coverage area. So the power is reduced. But there are certain problems are there in this, where if you only part of the cells are splitted, and here you have to handle the different size of cells. So look at here, these cells are with radius of R, whereas these splitted cells have the radius of R by 2. So at the same time you have to handle the cells with radius R and as well as cells with radius R by 2 simultaneously. And there may be a chance for arising of handoff issues. That is, high speed and low speed traffic can be simultaneously accommodated. So you could be very careful in handling this kind of situations. Next we move on to the sectoring. So here what we are doing is we are decreasing the co-channel interference. Co-channels are nothing but channels which are using the same set of frequencies where the interference is attempt to very low, and keep the cell radius R to be unchanged. Here we are trying to keep the cell size is unchanged, whereas we want to reduce the co-channel interference. What we are doing over here is we just replace the single omnidirectional antenna by several directional antennas. So look at here, in this cell, instead of a single antenna, we are going to use a 3 smaller size antenna which cover a particular region. Okay, so radiating within a specified sector. So the first image shows with the sector size of 120 degree, whereas in the second image, bottom image, we are using a 6 directional antennas for 60 degree directional pattern. So in such a way we can increase the number of antennas so that we could able to serve for all the areas, and interference also get reduced while considering the co-channels for the allotment. And third concept for improving the capacity is microcell zone concept. In this case what we are doing is at the corner of each cell. So look at here, there are 3 regions are marked over here. So at this corner we are going to place the antennas. So antennas are going to be placed in the outer edges of the cell. Any channel may be assigned to any user. So look at here, all the 3 zones are connected to the base station through the zone selector. So this zone selector will select any one of this zone, and mobile is served by the zone with the strongest signal, and there is a possibility of handoff within a particular cell. So there is no channel reassignment is required, and switch the channel to the different zone site also possible in this case. And second advantage about this microcell zone concept is we are reducing the interference because only the low power transmitters are employed. Okay, so in this way we are reducing the channel problems by assigning more number of users to the available channel. Thank you.